When I looked at this, it kind of reminded me of you guys did the iron and you put it in the blue solution, and in the blue solution was copper, and you guys said the copper plated on the iron. That's kind of what it reminds me of. But it's not. If you read the caption, it's iron that is reacting with oxygen to form iron oxide or rust. So what your author's done is at the top here, you can see the cute little iron atoms huddled together. So what would we call iron oxide? Would we call it a pure substance or a mixture? How many people think it's a pure substance? Iron oxide. How many people think it's a mixture? Why is it a mixture?
Because you can't separate.
Maybe this will help. Let's see, how do I want to do this? Fe solid reacts with oxygen in the air to form, let's make it iron 2 oxide. So FeO solid. Let's go ahead and balance that. I guess I need to put a 2 here to make sure I got 2 oxygens, and I'll go ahead and put a 2 over here to make sure I have 2 irons on either side. So what I just did, putting the orange 2, the orange 2s, went ahead and made it balanced. So anyway, if I do this, can you see that the iron oxide, now what do you think about iron oxide? Does anyone want to change their, is it a pure substance? It is a pure substance. It's a compound. Yep. So here's our butane lighter, and the formula for butane is C4H10. C4H10, so the carbons are black. Okay, and by the way, butane, how do I say this? Butane under normal atmospheric pressures and temperatures wants to be a gas. It's very volatile. So how do they get it in its liquid state is basically they pressurize the liquid, and they pressurize the gas. Okay, they pressurize the gas and make it into a liquid. So when you go ahead and you open the little vent thing, assuming you're just opening the vent thing, you're not striking the lighter, you're not striking it, those little liquid particles are going to want to go ahead and turn it back into gas, which is what they want to be under normal pressures, So it's inside there is a lot of pressure. So we said going from a liquid, what do you call it if something goes from a liquid to a gas? What's the verb? What's the name for that? There's 2 actually. Vaporization, yep, it's on the slide. Vaporization or evaporation, either one. And that's a physical change. The cute little molecules are the same before and after. So here it is. We've gone ahead and struck it. We've added a spark. And what the spark does is add energy so that the butane gas particles can combine with oxygen. And then we can write that chemical reaction like this. C4H10, that's butane, plus O2 gas. Actually, that's a gas now too. Goes to form, it's a straight combustion. If you burn like a hydrocarbon, like butane, you end up with carbon dioxide and water. So CO2 gas, carbon dioxide, and H2O gas. Is that balanced? No. And again, I'm kind of getting ahead of myself, but let me go ahead and I call it fix my carbons first. I can fix my carbons if I put a 4 in front of my CO2. Are my hydrogens okay? Nope. I got 10. I can get 10 hydrogens. How can I get 10 hydrogens over here with my water? If I put a 5 there, yep. So I usually balance my carbons and my hydrogens first. And then I'm going to go back and look at my oxygens. So, wow, I only have 2 here. Now, when we're counting oxygens, we got to be careful because I've got, how many oxygens do I have here in 4 CO2s?
8.
I have 8 oxygens. How many oxygens do I have here?
5.
I have 5. So, added together, I'm looking at, what, 13 oxygens?
Yeah.
Okay. Now, I'll explain why we can do this, because this is going to be kind of strange to you maybe. But if I want 13 oxygens, this is the only way I know how to do it, the best way. Actually, I'm going to go 13, but if I go 13, I've got 26, right? If I go 13 O2s. So I'm going to go 13 halves. This is how I balance it. And we'll talk about how you can get a half of an O2 molecule. We'll kind of get there. And if that drives everybody nuts, which it probably does, I do one last step for one like this. Let's see, if I take 13 halves times 2, what do I have?
13.
I have 13. Very good. Okay. So my last step is basically to multiply everything by 2. Everything. That means I'm going to end up with 2 times 1. I'm going to actually end up with, I'll go in orange. I'm going to end up with 2 butanes. If I scale this, you said if I take 13 halves times 2, I end up with, you told me 13. Okay, so I'm going to have 13 O2s. What's 4 times 2? 8. What's 5 times 2? 10. It's pretty messy, so here I go. I'm going to rewrite this silly thing. What about 2C4H10 plus 13 O2s goes to form 8 CO2s plus 10 H2Os? Let's double check. How are we for carbons? Does it work for us for carbons? Yep. Let's see, how many hydrogens do we have over here? We have 20 hydrogens, right? How are we doing over here? 20. And we already said oxygens, if I get 13 oxygens, I have 26, yep. Now this is where, don't feel afraid if you have to use your calculator. Oops, 26. Sorry. I read you're like, what? 16? 26 oxygens. And how many oxygens do I have with 8 CO2s? I have 16. 16. And then how many oxygens with 10 H2Os? I have 10. Yeah. So I do have 26. So that matches. So we'll be talking more about that later, but that's kind of how we chase that one down. Actually, you can go with the fractional number, the 13 halves, you can leave it that way. I'm cool with that. Or you can clean it up.
These are my favorite things. We did these in high school.
Everybody, go to JC. So chemical reaction. Remember, I kind of smiled when I was getting ready for today's lecture because remember when we were going to take the pizza and put it in the blender, take something heterogeneous, make it homogeneous, and we said that we could get our molecules of pepperoni and molecules of tomato, for instance, back because I bet pepperoni. Let's see, how would that work? Bless you. I guess it could go either way. Being an oil like that, or kind of an oily sort of thing, your pepperoni molecules might have a really low boiling point, okay? And your tomato molecules might kind of boil at, sorry, I meant to say a really high boiling point. It might be hard to get your stuff to boil, your pepperoni to boil, but it might be easy to get your tomato to boil. And so we can distill them. So if this is your pizza slurry, Basically, what you do is you adjust the flame, and it's not always flame. You could use different ways to kind of heat your mixture. But you kind of monkey with the flame to get a certain kind of boiling point temperature of your mixture. And so you kind of tease out the low boilers. Notice what happens is the low boilers will go ahead and gasify, and they kind of go up here, and then this condenser is chilled. So basically your vapor goes up, and it kind of spills over into a chamber that's cool, and so it will go ahead and condense and drip, 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 drip down here. So this is where you collect your pizza molecules or your pepperoni molecules or your tomato molecules. And then when you're all done with one fraction, then you go back up and you go ahead and jack up the temperature and get the next fraction. So that's kind of how that works. This one, I think I heard you guys, maybe when we were talking about mixtures, let's see. One way to separate a mixture, if one is a solid and one is a liquid, is just to simply kind of filter it, and that's all this is. Okay. So we're going to do these. Do you guys have answers to these? Okay. So I'm always going to go physical or chemical. So say you have a favorite shirt and you get bleach on it. Now, it's going to be a chemical change if you can't undo it, or you can only undo it with a chemical process. How many people think that's a physical change? How many people think that's a chemical change? Okay, so somebody says it's a chemical change. Why do you think it's a chemical change?
Because you'd have to add more chemicals to get it back.
That's kind of how I think of it. You would have to add more chemical dye to attach it to your shirt to get the color that you wanted back again. So that is actually a chemical change. That one's a tricky one. Okay, physical or chemical? So when we exhale on a cold day, the water gas or water vapor actually liquefies. It condenses to make that little mini cloud that you exhale because it's cold. So how many people think that's a physical change? How many people think a chemical change? Yeah, it's physical. So anytime, in this case, it's a phase change from gas to liquid. Yep, physical change. Plants use carbon dioxide to make sugars. How many people think that's physical? How many people think chemical? Me too. I'm going with chemical. Okay, looks like we have another phase change. What if butter melts? What do you think? How many people think that's a physical change? Me too. Yep. Physical change. Very good. Okay, so on your Unit 1 exam.
Okay, so what's the difference between the properties and the physical and chemical properties and physical and chemical changes?
Not much. They are totally very much related.
I'm sorry, 'cause I was confused on the how it's called bleach because it's changing the color, and is it color physical properties? So I was like,
Yeah,
oh, I mean,
That's true.
It could be chemical. I mean, it is chemical because of the bleach, but it could be physical too because
I see why you would
color's
say that.
changing.
so the property, that's a good example of, so the visible property or,
Visual.
the thing that we see changes, the physical property changes, but it actually changes at a chemical basis.
Because of the chemicals.
Mm-hmm. Yeah. Yeah. But otherwise, yeah, physical change and physical properties to me kind of,
Basically go hand in hand.
I think, and chemical change and chemical properties. Does anybody remember the third one up there? What is, and I always remember IN, intensive, what's an intensive property? Remember what word I said? I go with intensive.
It does not.
Right. It does not depend upon amount. Exactly. Independent. Yes, you're both right. So what's an example of an intensive property?
Reactivity.
Yes. It does not depend upon amount. I would really go with, for sure, conductivity. And if it reacts or not, yeah. My favorite one, independent of amount, was color. Yeah. Independent. Well, what's an example of an extensive property?
Weight.
Weight is a great one, yep.
Density.
Weight, and what'd you say?
Density.
Weight, density. Actually, density is independent of amount. Density is intensive. But extensive, it does depend upon amount, and weight depends upon amount. Weight's my favorite one there, too. Another, what does depend upon amount is, for instance, amount of energy given off when you burn something. So it depends if you burn one piece of paper or you burn 10 pieces of paper. Cool. I feel like we've kind of hit the other one. So here's homework that's due on Wednesday, and we'll kind of take a look at it together. And actually, we're not going to start the next part. While I'm thinking of it, though, if you want to bring your calculators Wednesday, you can, because part 3 kind of starts the numbers. So let's take a look at this together right quick. And should I still go ahead and push out send an email? Anybody need the assignment still? You got your book? You think so? Oh, I hope so. Anybody else need the assignment or whatever? Looks like we're good with the textbook.
I have 3 back, so she should have, we just turned one in, so that we just turned.
Got the hiccups. So you should do, these will be good for good exposure. So a chemical change, something new is formed. And then these last 2 all deal with, in the first case, it's aluminum. So if you take aluminum and you grind it, is that a physical or chemical change? And if you ignite it, is that a physical or chemical change? I think you guys will do fine. I don't have a lot to add to these. Any questions? Oh, just those 4 that was at the end of part 2. So those will be due on Wednesday. And they're kind of, I think, they're what we've been talking about in lecture.
So it just, okay, in Excel, just specify what they are.
Yep, you guys should do, I'm hoping do good on that. Yeah, we start numbers next week, okay? All right, have a great weekend.